Hi students, this section is 7.5, Special Types of Linear Systems. So in this section, we are now going to be determining the number of solutions that a linear system has. So what you'll see is when your lines intersect at that one point, that's going to be one solution. If you have two linear systems in their parallel, there is no solution, no way of lines intersecting when they're parallel. And then when you have a linear system and they equal the same, that's just one linear line, and that would be infinitely many solutions. So we're going to be looking at a one solution situation. We're going to be looking at a no solution situations and infinitely many solutions within linear systems in this section. So let's just get started with some examples here. It says, show this linear system has no solutions. So they are letting you know how many solutions this has, but they want you using specific methods to show that it has no solution. So they want you using the graphing method and substitution method. So here's our two equations. We have negative 6x plus 2y equals negative 8 and negative 3x plus y equals 7. For the graphing method, remember we need to put it in the form of y equals mx plus b. And so if I have here that negative 6x plus 2y, let's just put it in that form. Negative 6x plus 2y equals negative 8. I'm going to add 6x to both sides. So I have 2y equals 6x plus a negative 8, or I can just write it as negative 8. Either one works. We need y by itself, so we're going to divide both sides by 2. So y equals 3x minus 4. So that's the first equation. The second equation we'll put in the y equals mx plus b form. So we have here negative 3x plus y equals 7. Add 3x to both sides. So we get y equals 3x plus 7. So now what we're going to do is we are going to graph both of these and see what kind of lines they are. Notice my slopes. I want to point something out here. When you're looking at the slope of your equation, the 3x, notice my slope is the same. When your slope is the same, when the slopes equal the same, they are parallel. And I will show you that as we graph it. So let's graph the first one. We have we start at negative 4 on the y-axis, so we go down 4, 1, 2, 3, 4. My slope is 3x, so we're going to rise 3, 1, 2, 3 over 1. Again, it's going to be helpful to put a few points. Rise 3 over 1. Rise 3 over 1. And we're going to connect the points. Let's graph the second equation. My starting point is 7, positive 7. So 1, 2, 3, 4, 5, 6, 7. Put my point. Then what I'm going to do is my slope is, 3 over 1. So from there, I'm going to rise 3. And I'm going to run 1. 1, 2, 3 over 1. 1, 2, 3 over 1. Notice my lines are parallel from each other. So when they're parallel, that is a no solution. Let's see what that looks like with the substitution method. So with the substitution method, remember you're finding a variable and then substituting in to find your x and y. So if I have here negative 6x plus 2y equals negative 8, and negative 3x plus y equals 7. Let's solve for y here. So I'm going to add 3x to both sides. So I have y equals 3x plus 7. So I'm going to take that and I'm going to substitute it into the top equation. So wherever I see a y, I'm going to plug in that 3x plus 7. So we have negative 6x plus 2 times 3x plus 7. That equals negative 8. I'm going to distribute this 2 outside the parentheses to each situation in the parentheses. So we have here negative 6x. 2 times 3x is going to give me a positive 6x. 2 times 7 gives me 14. That equals negative 8. Notice my negative 6x and positive 6x cancel, and I have 14 equals negative 8. 14 does not equal negative 8, so that means it's a no solution. So determine if it's a no solution. If you use substitution method or the graphing method, if the lines are parallel, there's no solution, or if the left side does not equal the right side, that's also a no solution situation. Next example, example 2, they want us to show that these linear systems have infinitely many solutions and solve by using the graphing method and the linear combination method. So again, with the graphing method, you are going to put it into the y equals mx plus b form to graph this. So let's set this up. So we have 3x plus y equals 4. I'm going to subtract 3x to both sides. Y equals negative 3x plus 4. In the bottom one, we have negative 6x minus 2y equals negative 8. We're going to add 6x to both sides. So we get negative 2y equals 6x minus 8. Divide negative 2 to both sides. So we get y equals 6 divided by negative 2 gives me negative 3x. Negative 8 divided by negative 2 gives me 4. Notice when I solved and put both of these equations in the y equals mx plus b form, they equal the same equation. And when you have infinitely many solutions, that means that when you set this up and solve it, it's the same line. So I'm going to graph this. We start at positive 4, 1, 2, 3, 4. And my slope is negative 3x, which is negative 3 over 1. So I'm going to go down 3, 1, 2, 3 over 1. Go down 3 again, 1, 2, 3 over 1. And I'm going to connect the points. And I just draw one line because it's the same equation. And that's what an infinitely many solution situation is like. It's just the same line of the equation. Let's solve this working with linear combinations. So when we line this up, we have 3x plus y equals 4. And then negative 6x minus 2y equals negative 8. Remember, we want to either cancel out the x's, the y's, or x's or y's. So what I'm going to do here is I'm going to multiply the top equation by 2 so that I'm going to cancel out the x's. I need to distribute that 2 to each situation here for this equation. So I have 6x plus 2y equals 8. And then negative 6x, I'll just rewrite the bottom equation. Notice my x's cancel. Notice my y's now are canceling, positive 2, negative 2. And 8 plus negative 8 or 8 minus 8 cancels as well. So this is a 0 equals 0 situation. And so 0 equals 0, this is infinitely many solutions. And that's my answer. So these are two different ways you can solve these equations to determine how many solutions. Now, Another way you might see some of the questions in this section is they are not going to tell you how many solutions it has, where you are going to identify the number of solutions for the linear system. So now you're going to have to determine, are you going to use the graphing method? Are you going to use the substitution method? Or are you going to use the combination method? Well, here I have 6x minus 2y equals 10. Negative 3x plus y equals 12. It doesn't matter which method you use, whatever you want to get your answer. You would have to show your work and then answer the question. I'm going to solve using linear combination method. So with that, my x's are lined up, my y's are lined up, and my numbers are lined up. I'm going to cancel out the x's, so I'm going to multiply my bottom equation by 2 so that I get a negative 6x. And I'm going to distribute this to each situation here. So I'll rewrite the top equation, 6x minus 2y equals 10. The bottom, 2 times negative 3 is negative 6x plus 2y equals 2 times 12 is going to give me 24 here. Notice my x's cancel, but now my y's cancel. So I'm left with 0 on the left side. And does that equal the right side? Well, 10 plus 24 gives me 34, and they do not equal. So since they do not equal one another, this is going to be a no solution situation. Remember, with a no solution situation, the equations equal. So if I did set this up to graph it, I could put this in the y equals mx plus b form. And so we have 6x minus 2y equals 10. I can subtract 6x to both sides. Negative 2y equals negative 6x plus 10, and divide negative 2 to each situation. So we get y equals 3x minus 5. And if I set it up for the other situation, the bottom equation, negative 3x plus y equals 12. If I add 3 to both sides, 3x, I get, here I'll write it over here, y equals 3x plus 12. Notice my slopes are the same, so they're parallel lines. So this would be a no solution because of the parallel lines. They're never going to cross or intersect. So that's my answer, no solution situation. And that is it for this section.